11.1, we are now officially going to use the process called completing the square. And there is a connection with what we did in Unit 10 with Unit 11. In Unit 10, we talked about standard form and vertex form. And we never showed you that, we told you that these two things are equivalent to each other, that they were two ways to see the same parabola. But we never told you that how to go from this form into this form. And that's because you did not know how to complete the square. So what we're going to do is we're going to change things that are written like this into vertex form. And the way we're going to do that is by completing the square. That's the reason why our class did 11.0 first, because I wanted you to see that process using the algebra tiles of how to complete a square, because it's the same process for doing this with quadratics. Okay? What are we going to do? We're going to figure out what C is. How do we do that? We figure out what B is, and we do half of B squared to figure out what C is, and we simplify this. Some of the problems we're going to have to do, we're going to have to factor them, just so you know. How are we going to transform things from standard form into vertex form? We're going to move C to the other side of the y side of the equal sign by doing the opposite. We're going to leave an underscore. That means like a blank space with like a line. An underscore is just a line that is at the bottom of something that you put above it on both sides. We're going to add half of b squared in the underscore on both sides. Whatever we do on one side, we do to the other. We're going to simplify and combine the numbers on the y side, and we're going to factor the other. And we're going to move k to the opposite side of the x side by doing the opposite. You'll see what that means. I believe fractions are easier to use than decimals. I explained that in 11.0. GCFs matter, especially on number 16, 17, and 19. I will do one of those as an example with you, but those are the hardest ones on this whole worksheet. The reason for that is sometimes the A value is not 1. When the A value is not 1, 16, 17, and 19, you have to do a GCF on that problem. If you're not doing the GCF, then you're not doing it correctly. I will give you an example about that right there. So, let's do some problems together so you can see how this is connected to what we've already done. If you are not in my class and you're watching this video, I might recommend that you go back, if this isn't making sense, to watch the 11.0 worksheet video. We did that, and I think it was 25 minutes well worth the explanation. Okay, here's number 3. Find the value of C in the expression that completes the square, where C is equal to, right here goes B over 2 in parentheses squared, and then we're going to write it in factored form. So we have two things to do. If they give us this B value, we got to figure out what C is. So the B value here is negative 6. Half of negative 6 squared. Half of negative 6 squared is negative 3 squared. What does that make? If you know, say it out loud. I agree. That's what goes in the blank. That's your C value. Then write it in factored form. This makes a perfect trinomial squared. This factors perfectly into something squared, and something goes here. It's this simplified. Not the square part, but this part simplified, the B over 2. Half of 6 over 2 is negative 3. The negative sign makes this D value negative. What happens if it's a odd number? Well, that doesn't change anything. If we don't know what half of 5 is, or if 2 does not go into 5 evenly, leave it as a fraction. When you figure out what goes in the blank, you square the top, you square the bottom, and you just write that as what goes in the blank, 25 over 4. That is a perfectly good answer. Don't switch it to a decimal. Don't turn it into a mixed fraction. Just leave it 25 over 4. And then when it factors, all you're doing is leaving it just like this in factored form. It's just b over 2. Because if you FOILed this out, you would get those 3 terms. It's going to work this way every single time when you complete the square. It's great. It's a great technique. Now, how we're going to use this is kind of what we did in 11.0. But once we get to number 11, things are going to change because there's going to be a y equals in your problem. And this is standard form. And we need to put it into vertex form by completing the square. So what I told you to do, you have 5 steps. We're going to move C. We're going to leave underscores. We're going to add half of B. And so if you have your 5 steps, keep that right next to your worksheet. Step number 1 says move what? We need to move the negative 26 by doing the opposite. Since we're subtracting 26, what's the opposite of subtracting 26? Whatever you do to one side, you do to the other. 26, take away 26, makes 0. I'm not going to write that. Over here, I'm going to put y plus 26. Step 2 says something about an underscore. What does it say? Somebody read their notes. Tell me.
Underscore on both sides.
Underscore on both sides. This is what that means. Put an underscore. You should have room because something needs to go there. We're going to fill in the blank. This reminds me. Step 1, move the C. Step 2, write underscores on both sides. Step 3 says add half of b squared. Thank you. What is half of b squared in this problem? Half of b squared. You see it? If you don't know the b value is negative 10, we're going to put half of 10 squared, and that's what we're adding to the right-hand side. That's what's going in the underscore. On the left-hand side, next to the y value, we're going to simplify that. Half of 10 is negative 5. Negative 5 squared. Negative 5 squared is, we're really adding 25. Here we're adding negative 5 squared, by the way. I'm just kind of like doing that in my head. We took the b value. We said, what's half of that squared to this side? Whatever we do to this side, we do to that side. But step 4, if my memory serves me correct, it says something like simplify and combine the number on the y side. We need to put these two numbers together. Simplify it. What is the 26 plus 25? If you need a calculator, use a calculator. But some of you can do that in your head. What is it?
51.
Y plus 51. It's a positive 51. On the right-hand side, there is no need to do any work because you just completed the square. This is going to factor perfectly every single time. If you did it the right way, it's going to factor perfectly from this ugly mess into something nice and pretty and satisfying. Like some of you. Yeah, there you go. Some of you. Yes. Not all of you. Some of you. That's funny. That makes me laugh. No, all of you. All of you are perfectly satisfying in your own ways. That's good. Yeah, that's good. What goes here? It goes the b over 2. The b over 2 is -5. This is a perfect trinomial square that half of b always ends up being the d value, that thing right there. We're almost done. There's only one more step, I think. Step 5. Doesn't it say move this k value? This is called the k. We move it to the other side. We subtract 51. We subtract 51. Y is equal to x minus 5 squared minus 51. And now it's in vertex form. If you remember vertex form from the previous lesson, what you'll remember is opposite, same. Because they're going to ask you, what is it in vertex form? Here's your answer. Y equals parentheses x minus 5, parentheses squared, minus 51. And they're going to ask you, what's the vertex? Opposite, same. HK. Opposite is a positive 5. Same is a negative 51. And if you understood what we did, it's the same process we did in the first worksheet with this one. The only difference is there's a y value that we have to play around with. So I don't feel that after doing one example you'll understand what we're doing yet. So I want to do another example with you. I did 11 with you. I'd like to also do number 12. And hopefully it will start making sense to you. We're doing the same exact thing as we did before. Do you know what your first step is? What are we going to move? What number are we moving first? Say it out loud. If you said 57, good. Are we going to add it, subtract it, multiply it, or divide it? Over on the left side, you might as well just write y minus 57 underscore equals x squared minus 18x, and 57 minus 57 makes 0 underscore. We put the underscores there, these little blank spots, because something has to go in them. That's step 2. Step 1, move C. Step 2, get these blank spots. Step 3, we have to add half of b squared. Here's my b, half of it squared. Some of you are going to go, oh, that's a plus -9 squared. Perfect. Whatever you put into this underscore, you need to put into the other underscore. Over here, you don't need to simplify it. Over here, I say simplify it. What is -9 times -9? You might as well put plus 81, because that's what it is. There's no need to. The reason why I would not recommend simplifying this is because this is going to factor perfectly. The next step is to go from this mess to this. And I hate to say this, but I call this the ugly duckling. It goes from something ugly to something pretty. Goes from the ugly duckling into that beautiful swan, right? You've heard about that story when you were kids?
No.
So we need to figure out what 81 minus 57 is. I'm going to use my calculator for that because that's a big number. We're almost done. This is your H, this is your K. But I have to move the K on the other side because that's what we've been doing. Opposite, same. That way we can plug this into our final answer. And now we know what the vertex is of this parabola. What is the vertex? Opposite of this for your x-coordinate, it's going to be 9. Same, -24. It's not that hard. The only way this gets harder is if the A value is not 1. 16, 17, 19. The hardest ones. What do we do when there is an A value? Well, everything stays the same except the A value needs to be 1. If not, use a GCF, and GCFs matter. Especially what goes in the underscore. I'll explain what this means on this problem. If you need to write extra notes to yourself, let's write extra notes to yourself. Same first step. What do I move? What's the opposite? Still leave the underscore. Equals. Still need an underscore. But here's the deal. This is not a perfect square on the left-hand side. X times x is x squared, but 2x squared is not something that would make that perfect squared trinomial. Because there is a 2 there, we have to factor out a GCF of a 2. So there's going to be one extra line just like this. I need to factor out a 2 GCF from this whole thing. When we do, the 2 goes in front. If I factor out a 2 from the 8, what does the 8 become? 4x. Don't forget the x. The underscore still stays there. And then we have parentheses. So this isn't the hard step. The GCF step isn't where students mess up. Where students mess up is what happens, what we put into the underscore. Now, we still do half of b. What is half of b? We still add 2 squared, but because we're adding 4 here, we're not really adding 4 over here. Remember how this was blank? You're adding 2 times 4. You're adding the GCF times whatever you put into the underscore. We're actually adding 8 to the left-hand side. This is equal to this, but we've added 4 blue units, so 2 times 4 means we're actually adding 8 units on the left-hand side. That is the number one mistake students forget. But it doesn't have to be. You can remember it. I'm actually adding 2 times 4. Now everything goes from something, remember I said the ugly duckling, the swan? This right-hand side, the 2 stays there. It factors something nice and neat. X plus 2. Boom, no work to do. You just take that value, put it right there. On this other side, we have to go 7 plus 8. 7 plus 8 is y plus 15. And then we move it over. So now I know what my vertex form is. 2 parentheses x plus 2 squared minus 15. What that 2 does is it makes it more narrow. That's all it does. You still have opposite, Same for your vertex. Opposite is -2. Same as -15. So I'm going to put a little star right there because that's the thing where most students will forget. If you want to put a little star there, that's going to help you remember what to do when you're doing number 17 and 19 on your own. Okay? I'm going to give you the remaining amount of time to finish 11.1. 11.0, 11.1 are due next class.